Thank you, Tiziano. So I've been in networking, unfortunately, really for around 35 years, and I've seen the same thing being repeated over and over again. When Tiziano asked me whether I would be willing to have a talk for NAMEX, we quickly agreed that this might be the perfect topic. Here's a brief overview of who I am and what I'm doing, and I will just skip it because I have 28 slides to cover in 30 minutes. So if you want to know more about me, just go to ipspace.net and start exploring. The first thing that a lot of people will tell you is that technology doesn't matter anymore because we are software defined and who knows what else. That's totally bogus and false. Technology still matters regardless of what the vendors and marketers are telling you. And they will tell you that it's all about the services and it's all offloaded and it's all in the cloud and you just need a credit card and it's all yours. Unfortunately, someone still has to carry the bits, and obviously everyone doing the marketing about overlay virtual networking and how we no longer need the network and whatever forgets that the bits still have to move from here to there. And selecting the right technology to move bits obviously helps. You might remember, if you're old enough, that we started with dial-up, and then there was X25, and then there was frame relay and ATM. And for whatever reason, everyone is using IP and Ethernet today. And you might wonder what that reason is. And it's very simple. It's simple, it's cheap, and it doesn't have many features. If you are old enough to remember the alternatives to Ethernet, like Token Ring or FDDI, they're all gone for a very simple reason. They were more feature-rich, they were thus more expensive. And once you get to the point where you have enough bandwidth that you stop caring about the last 10%, or when we went from shared Ethernet to switched Ethernet, those extra features just, added the cost that was unnecessary. And so all these more complex technologies faded away. The same thing happened with ATM. ATM was a great idea, but once you have enough bandwidth, who cares if every session, if every user has a separate queue? I mean, look at us, we are doing this video conferencing over internet that has absolutely no QoS, and it works well enough. So why should we care about more complex technologies if throwing a bit more bandwidth at the problem is good enough? However, you can't beat the laws of physics. And this is the problem that I see a lot in the recent years, where everyone is talking about software defined and software this and software that, and people keep forgetting the fundamentals. My favorite one is obviously the virtualization vendors happily telling you how you can migrate the workloads into the cloud, sometimes even running workloads, and they keep forgetting that, if you want to compute, you need data. And data has to be somewhere. And if the data is not next to your compute node, then there will be latency. And they conveniently forget all that and claim that with software-defined whatever, we can do miracles. We can't. The speed of light is what it is. The serialization delay is what it is. The bandwidth is what it is. And we have to work within those parameters. There's absolutely nothing you can do to, change the speed of light or to get data from here to US any faster than you can on a fiber optic cable. Well, actually, that's not exactly true, because once we get to the low orbit satellites, then we will be at the actual speed of light, but we are not there yet. The other important thing to keep in mind is that the fundamentals haven't really changed in the last 50 years. There's this famous RFC 1925, and it talks about 12 truths of networking. And one of them is that every old idea will be presented in new clothes, regardless of whether it worked or not. So if you take a look at the modern stuff like network automation, we've been doing that in 1990s. If you segment routing, for example, we've been doing that in token ring. It was called source route bridging. For almost every supposedly hip new idea, you can find an equivalent in the good old days, and then you can quickly find why the new idea will not work. The old idea crashed, so probably the new idea will crash as well. Also, the really sad part is that networking really hasn't changed much in the last 40 years. I mean, once everyone standardized on IP, all that happened in the last 40 years is that we got 4 times longer addresses, that we don't use anything below IP but Ethernet, that we got a number of security issues with IPv6 because those people thought that they need to reinvent everything we ever did. And the only thing that is happening these days is that we might see TCP replaced with something that is better suited to weird environments like mobile networks. And of course, every now and then someone tries to reinvent the old stuff like large-scale bridging. I remember the good old times when we had bridged networks across the whole country, and then someone started a broadcast storm and brought down the whole country. Today we are doing that on data center scale, or maybe a few data centers at a time. And then people will realize this is stupid and go back to routing. And then when everything works, someone will bring bridging back. And so we'll go back and forth forever. I just collected a few of the fundamentals that we love to forget when we are talking about exciting new stuff. What we're doing and what works well is deterministic simple packet forwarding in the core with complexity at the network edge. So for example, every router between myself and yourself is just forwarding IP packets. No one is doing QoS in the internet core because that wouldn't work. And the video conferencing software is handling all the complexity. Also, it's really important that you have local feedback loops that adjacent devices can figure out what's wrong, and that the devices are autonomous. So even if the central brain dies, if the controller goes down, we are still able to do something. Another very important principle is to have minimal state in the core. The moment you start inserting information into the network, you will get to the point where things will just stop working because there will be too much information in the network. And finally, we should have very, very simple service contracts instead of some convoluted stuff that no one understands or could implement. Of course, we keep forgetting this, so we get large-scale bridging or we get cache-based forwarding. If anyone remembers the old days when Cisco had fast switching and the internet melted down because fast switching cache was trashed with distributed scanning, today people are reinventing cache-based forwarding with all sorts of things like Lisp. Also, we never learned that centralized control plane is bad. All those ATM and frame relay networks didn't teach us anything. We have to reinvent the wheel, and it's called OpenFlow and SDN. Of course, it works as well as it did in the past. It doesn't. Then there are people who love to have state in the core. There are people who love to build traffic engineering tunnels all across the network with every node having a tunnel to every other node until everything crashes, and then it takes days to recover. That's what one of the Japanese service providers supposedly learned after a major earthquake. We also love solving application problems in the network instead of pushing them back to where they belong, to the software developers, and I'll talk about that in a bit. And every time you are trying to solve an application problem in the network, you are creating problems for yourself that you will never get rid of, because whatever you deploy can never be turned off. And one of these application problems solved in the network, as an example, is QoS marking at the network edge. Whoever got the crazy idea that the network should mark the packets instead of just enforcing the service contract? I don't get it. I mean, vendors love it because it allows them to sell more complex stuff. Which brings me to the next point, also from RFC 1925. Namely, it is possible to make pigs fly. But it's not a good idea, and you wouldn't want to be sitting under them as they fly overhead. And another grumpy networking engineer, Randy Bush, once made a comment that maybe we can't afford the fuel cost because, you know, if you want to fly the pigs, someone will have to pay for the fuel. And who's that? That's us. And who wants to fly pigs anyway? Anyway, flying pigs bring me to the next lesson, namely, complexity will kill you. Doesn't matter, you might survive for a very long time, but eventually, the more complex network you have, the easier it will be to crash. And the same Randy Bush made another point on complexity. Complexity is the arch enemy of scaling and hence of the bottom line. The more complex your system is, the more expensive it is to operate. I would strongly recommend you read RFC 3439, which says, for example, that complex architectures and designs have been among the most significant and challenging barriers to building cost-effective, cheap, large-scale IP networks. And there are a number of reasons why we build our networks more complex than they have to be. Reason number one is because we think that we are as big as the big guys, and therefore we have to use the same solutions as the big guys. And someone made this fake O'Reilly book title named Solving Imaginary Scaling Issues at Scale. And this is what a number of people do. For example, I've seen a design where someone wanted to use BGP with EVPN, with VXLAN, with all the bells and whistles in a data center fabric of 4 switches. Now, why would you ever want to have all that complexity for 4 boxes is beyond me, but the vendor loved that design. Another lesson learned, you're not Google. You will never be Google, and whatever problems they are solving probably doesn't apply to the problems you have to solve. And also keep in mind that Google talking about their problems is really just a recruitment drive because they want to tell everyone else how cool they are and, oh, come work for us. The next major source of network complexity is networking engineers trying to be heroes. Instead of saying, we don't do that, and here are 5 reasons why we don't do that, and this is what we should be doing, please go and fix your stuff so that we will do it the right way. We try to be MacGyvers. We try to solve the problem. We try to save the day. And so on a Friday evening, when the software has to be rolled into production, and there's a missing thingy in the network, instead of saying, where have you been for the last 6 months when you've been developing the software, we go and fix the problem. And once you fix the problem this way, this fix will never go away, and you will always be trembling as you go on vacation when your mobile phone will start to ring because this thing exploded into someone's face when you were away. And obviously, because documentation is not the first priority for any networking engineer, right? we never documented exactly what we did. So all those wires glued together on that table were never properly documented. Now, I already mentioned Friday evening, right? This is my view on why we are dealing with so much complexity in our networks. It's a management problem. The managers are allowing software developers to pretend that the laws of physics don't exist. So they do whatever they do, they push the problem down to the service people, and the service people try to do the best and push the problem down to the virtualization people. And then someone comes along with high availability requirements, and someone else says, well, we can just move this server from Rome to Milano, why not? And then the white substance flows down and hits the networking team, and we have to deal with it. Or, I love the other meme on this slide, worked fine in dev, I threw it over the wall, it's ops problem now, I stopped caring. The problem is that most of the time, these actions are totally unnecessary, because you, as the networking engineer, you get a request from, let's say, the virtualization people, because they think that this is the way to solve their perceived problem. But no one ever asked, what does the customer really need? Not want, not think they need, not perceive they need, not what the vendor has told the customer they need, or what the customer read in an industry magazine or on a website, or heard in a conference talk, or overheard on a golf course. Let's focus on what the customer really needs. And usually, it's as simple as that tire there to have a swing. And obviously, everyone else would try to sell them anything else. Now, I have to mention the last source of complexity, your inner nerd. This is based on a true story. I did hear of someone who tried to persuade the company to migrate from OSPF or whatever they were using to ISIS with the new data center fabric, with the hidden agenda that he needs hands-on practice for his CCIE exam. Now imagine you're risking the stability of your corporate network just so that you could get some more hands-on exercise. I'll leave you with that. Now, these were the inside-facing issues. Now let's talk about the customers. Because honestly, it is all about services, and yes, customer is the king and all that, but some services are simply not worth delivering. And no one gets it. In particular, if the organization is sales and marketing driven, and salespeople bringing in revenue are heroes, and the networking people having to implement that are, you know, just the naysayers who can never get the job done on time. So thinking about customers, I identified 4 types of customers. We have the enthusiasts. They are a bit dangerous because they want always to try the newest stuff, and they want to play with thingies, and they believe in the magic power of technology. So be careful. Then you have the best customers you could ever have, the evangelists. These are people that are so happy with you that they go out there and they tell everyone else how awesome whatever you think is. Unfortunately, they're rare. Then you have the mainstream customers. Hopefully, this is like 95% of your customer base. And then you have those that I can only call patients. People who always want some extra treatment, who always want something different from what you're offering, but would never pay the price. They want to have the lowest possible price for you to do magic. So the only way to handle them is to stay away from them. Identify them, figure out the total cost of delivering the service to such a customer, and if you can put together a business case, the CFO, the financial guy in your company, will be your friend. Because what you should do with these people is you should not focus on the revenue you will get from them, but on the profit you will make on them. And quite often, and I've seen quite a few of this in my 35 years. And when I was still in charge, we walked away. And then when other people were in charge, they were less successful identifying some of the patients. And there are some horror stories behind that. Anyway, do use this quote from Marco Visser. He was head of KPN, that's Netherlands mobile operator, mobile services division. And in June 2009, they decided to stop offering prepaid phones because they were losing money on that. And when asked about that, he told the industry press, my competitors are welcome to those customers because they will make losses on them as well as I do. If you fall in the trap of creating special stuff for these special customers, then you will eventually get to this point, because every quick fix you make will haunt you forever, and you will never ever get rid of the technical debt you created to bring in that one special customer that negotiated such a low price that you're effectively losing money on them every day you are offering them services. So keep this in mind. Right. With all these negative things being said, let me conclude with what I think you could do to make things a little bit better. First, please always identify the root cause of the problem. I'll just tell you a simple story. I was working with a customer who lost 2 data centers because they were smart enough to stretch VLANs across 2 data centers, and obviously they got a bridging loop. They lost 2 data centers. So we tried to identify what the problem was, and it turned out that some virtualization consultant told them that they need this networking infrastructure. And whenever a virtualization consultant is talking about networking infrastructure, grab your wallet. So they told them that they need this networking infrastructure to support disaster recovery. And in the end, it turned out that the solution wouldn't work at all because it was broken. So they lost 2 data centers that would have been happily operated because they had no disaster, just because they were listening to someone proposing a wrong solution. In the end, it turned out that the whole thing was as easy as recreating subnets after the disaster struck, and they had like 4 hours to do it. So always try to find the root cause, and when you find the root cause, keep everything as simple as possible. So instead of, to use the same example, instead of stretching VLANs, maybe write down a process to recreate the subnet, problem solved. Instead of implementing some crazy QoS scheme, maybe it's cheaper longer term to throw more bandwidth at the problem. Instead of, I don't know, having some convoluted marking at the network edge, maybe it's simpler to say, you mark your traffic and I will only enforce that you don't go over the quota. So try to find the simplest possible solution to solve your problems. And once you get there, and once you minimize the set of things you have to configure, it's possible to automate everything and finally move from medieval craftsmen in guilds making shoes, you know, where every pair of shoes was handmade, tailored to the customer, to where we are today in 21st century, where robots are making everything, apart from networks, because networks are special and we have to build a snowflake, a special network for every customer. One final thought. Don't think that technology will save you. Most of the problems we have are the business problems or the process problems or people problem or perception problem or whatever it is. It's rarely technology. And if you don't change the root problem, if you just keep throwing technology at the problems you have, don't expect different results. Doing the same thing with different tools and expecting different results is the definition of insanity. It wasn't Albert Einstein, by the way, but I love his face on this quote. And that's it for today. Hope you got something useful out of this presentation. And if there are any questions, Tiziano, I think we still have 5 minutes left, right? Oh, and by the way, these are my coordinates in case anyone wants to get in touch. So just send me an email and I'll do my best to answer.
Not work.
Okay, now I can hear you, Tiziano.
Yeah. Thanks a lot, Ivan. Very beautiful presentation as usual. As a matter of fact, there is only one question for the moment, but it's not really, it is not technical to tell the truth. So I will leave it for the as a final question. If there are any questions from the audience, it will be more than welcome. For otherwise, I have a couple of. As a matter of fact, I have hundreds of questions for Ivan, but you know, I have to.
Okay, let's start with the first.
Okay, no, okay, there is a question now. No, there's no question. Just okay. Let me make you my first questions. And you know, you in the past have worked a lot in MPLS field, and what kind of future do you foresee for MPLS? It's a very old standard, but very used. Because my opinion is that MPLS services will survive, but without classical MPLS protocols such as LDP and RSVP-TE, probably in a simplified environment. You know, segment routing is changing a little bit the paradigm, but the services are not changing. So it would be great to have your opinion. What is the future for MPLS?
Well, as you already said, there are two parts to MPLS. There's the data plane, there's the control plane.
Yeah.
Turns out that you effectively need some metadata attached to a packet, for example, to identify the service or tenant or what have you. This metadata is effectively what we are doing with MPLS labels. So yeah, it will stay there in one form or another. MPLS has the advantage that it's built into almost all hardware out there. So deploying new stuff on MPLS is, you know, a piece of cake. The drawback is that you do have to have MPLS transport end-to-end, and people are getting around that by using MPLS over GRE or UDP or what have you. The other option is obviously something like network services header that didn't really catch on, or segment routing v6, which yet again faces the problem of not being supported in hardware apart from a few high-end ASICs. So yeah, I agree with you that MPLS data plane won't go anywhere. On the other hand, the control plane has already been significantly simplified with segment routing based on IGP. So you don't need IGP plus LDP, you can just use IGP with segment routing TLVs. As for MPLS TE in whatever control plane variant, it's the question of whether people will want to, whether they will want to deploy, you know, a centralized controller to do that, in which case you don't need any complex protocol in the control plane because the controller can program everything, Or on the other hand, if you still want to have autonomous tunnel establishment, then you will need something. And so RSVP will probably stay there for a long time.
Okay, now I have plenty of questions for the audience, and two of them from my friend Luca Cicchelli, who works for our topics, is another internet exchange point in the northwest of Italy. It's located in Turin. So the first question is, any quick suggestion for internet exchange point in the future?
Well, I would say
probably they have to move to a more modern fabric.
Well, as we all know, internet exchange points are one of those environments where you absolutely need layer 2 fabric.
Yeah.
Unfortunately. A number of exchange points are doing is to run the layer 2 fabric over VXLAN so that you offer layer 2 services at the edge while having totally stable IP core in the middle. So that's one thing I see going forward. Smart people don't use EVPN with that. They use static flood lists and dynamic MAC learning because that works well enough for any reasonable sized IXP. So yeah, decouple services, the layer 2 transport from transport, build it on top of IP core, and keep things as simple as possible. But I guess that the smart IXP is already doing all of that.
Unfortunately, there is no room for other questions because we are going over time, but there is last one, which is not technical. Always my friend Luca Cicchelli told which background they using, even maybe in Slovenian mountains?
Yeah, this is a mountain I climbed on Saturday. It was beautiful weather. This was the crux of the route, and my mountain guide took a picture of it just before I had to climb.
Okay, Ivan, it was a real pleasure to have you here, and we have to close, unfortunately, but I would stay here for hours, but it is not possible. So thank you very much, also from my friends of NAMEX, on behalf of my friends of NAMEX, and hope to see you, in physical next year or somewhere, in the future, sometime in the future, somewhere and sometime. Okay.
That would be great. Thank you. Thanks for having me.
Thank you, Ivan.